Okay, so now we'll go to exercise 7.3. It's again based on all layer formulas and points were mentioned for integration. So let's go to the first question. Question is integrate the following functions. Question number 1 here, integral of sine square 2x plus 5. Now if you remember, in integration, if you have sine square or cos square, we use the double angle formula. So here double angle formula 1 minus cosine double angle here 4x plus 10 the whole by 2. Right? You know sine square x equals to 1 minus cosine 2x the whole by 2. This is what we have used. If you remember, those points to remember there. If you just recall these points here, the one of the point was this. If you recall, if you have sine square or cos square, use the double angle formulas, right? So every day you just recall these points, you will realize. Okay, now this can be integrated very easily. You know, half being constant outside, here 1 minus cosine 4x plus 10 the whole dx. So half as it is. What's integral of 1? That is x. Integral of cos, which is sine 4x plus 10 upon the coefficient of x, which is 4 plus c. This is required integral. If you want, you can write one more step here. 1 by 2x minus 1 upon 8 sine 4x plus 10 plus c. You can write this step if you want. The important step is double angle formula here. Remember, if you have sine square or cos square, we go for double angle formula. And here, this being a linear function, you have considered this as x. What's the integral of cos, which is sine? This one as it is upon the coefficient of x, which is 4. Next question. Question number 2. Integral of sine 3x into cosine 4x. Product of two trigonometric functions, use vector formula. So you need 2 here. So multiply and dividing by 2. Twice sine 3x into cosine 4x. Now what is this? This is 2sc. What is 2sc? That is nothing but, if you remember, 2sc is nothing but s plus s. You know, s plus s is 2sc. So let's use this from trigo. So sine here, this plus this 3x plus 4x, which is 7x, plus sine here, this minus this, which is minus x. What you did nothing, just vector formula, remember, s plus s 2sc. Now one more step before I integrate. Here sine 7x as it is. Sine is an odd function, so this minus will come out and then we'll integral. Okay, now final step, integration. Up to this it was trigo, remember. Integral would be always last step. Half. What is the integral of sine? It would be minus cosine 7x upon the coefficient of x, which is 7. Plus here, why plus? Because the integral of sine is minus cos. So plus cos x plus c. This is your answer. If you want, you can take 1 by 2 inside the integral. Next question is about integral of cos 2x, cos 4x, cos cx. Product of trigo functions. So 11th standard trigo, we need to simplify this, and product should be expressed in form of plus or minus. So we use just, 2cc formula first. So half you required half here, twice bigger angle I'll write first, cos 4x into cos 2x. Let me keep cos 6x as it is. Any two functions can be combined, remember. So this is half as it is. What is 2cc? Vector formula, c plus c. So cosine alpha plus beta, which is 4x plus 2x, 6x, plus cosine 4x minus 2x, which is cos 2x, into cos 6x as it is. Now if I open the bracket, again you have product of trig functions, so simultaneously multiplying dividing by 2. So twice here cos 6x cos squared 6x, here twice cos 6x into cos 2x. Product of trig functions here. Product of trig functions, this is cos squared. Now you know if you have squared, use double angle formula here. So 2 as it is. What is cos squared 6x? 1 plus cosine 12x by 2. So this 2 will goes away, plus now 2cc. What is 2cc? It is c plus c. So cosine 6 plus 2, 8 plus cosine 6 minus 2, which is 4, the whole dx. Okay. So now finally we have 1 upon 4 here. This is 1 plus cos 12x plus cosine 8x plus cosine 4x. So this is the most simplified form. What is this? This is not integration, remember. This is just 11th standard trigo, remember. This is trigo. Integration will be last step now, right? Every time you must have noticed that in integration the final step should be the final standard form. Integral of 1x plus integral of cos 12x, you know, sine 12x upon 12, linear function, upon the coefficient of x. Sine 8x upon the coefficient of x, 8. Sine 4x upon the coefficient of x, which is 4, plus c. This is your final answer. If you want, as you know, you can take this 1 by 4 inside the integral, inside the bracket. Okay, so this is the final integral. What is the important step? One of the points, if you have product of the trig functions, use the factor formula. So I've used the factor formula twice. Squared, use double angle formula. Fourth question, question number 4 here. Integral of sine cube 2x plus 1. Okay. Now you just recall, you know, sine 3x equals to 3 sine x minus 4 sine cube x. If you remember, one of the points to remember, I told you when you have sine cube and cos cube, use the formula. This point number 6 here. If you have sine cube and cos cube, use this formula and make the sine cube as a subject of the expression. So I'm using this. That 2x plus 1 is not important because it's just a linear function. So you just make this as a subject of the expression here. So I'll take this one over here. Sine cube x equals to 3 sine x minus sine 3x the whole by 4. But I don't want x. What I want here 2x plus 1. So finally the integral would be 3 sine, instead of x you have 2x plus 1 minus sine 3 times this. So 6x plus 3 the whole by 4, the whole dx. I hope this is clear to you. What I did in this, you need 2x plus 1. So in place of x, you wrote just 2x plus 1. So 3 into sine 2x plus 1 minus here multiplying with 3. So 6x plus 3 whole by 4. Now this can be integrated very easily, you know. 1 by 4 being constant outside. What about this? 3 being constant as it is here, integral of sine, which is minus cosine 2x plus 1 by 2 coefficient of x. Integral of sine is minus cos, so plus cosine 6x plus 3 the whole by 6 plus c. Okay, so if I take finally this one inside, the final answer is this here. Finally, minus 3 by 8 cosine 2x plus 1 plus here 1 upon 24 into cosine 6x plus 3 plus c. This is your final answer. There are some other ways also to integrate this. Your backside answer may not be exactly like this sometimes, remember, but it can be rearranged like that form. But don't worry, this is standard and correct way of doing this integration. Question number 5 here. Sine cube into cos cube. If you remember what we do, we just multiply and divide by 8. If you recall, one of the point number 8. If you have sine cube into cos cube, multiply and dividing by 8. So I'm doing this, multiply and dividing by 8. So this is 2 sine x into cos x, the whole cube. You must have realized what I did. 2 cube is 8, sine cube, cos cube, I've taken cube outside. Now what is that inside the bracket? This is sine 2x. So sine cube 2x. Now it's like previous question only. Okay. And what was the previous question? The previous question was, instead of x you had 2x plus 1. That's the only difference. So just do like the previous question. I'm not doing. Question number 6. Again it is known to you. Integral of sine 3x into sine 2x into sine x. It's just a product of trig functions. How do we do product of the trig functions? Factor formulas. Now if you remember, you have c minus c equals to minus 2ss. So you require minus 2 here. So multiply and dividing by minus 2. So minus 2 sine 3x into sine 2x and sine x, let's keep as it is. Minus 2c, we are going to write what? Minus 2ss, you are going to write c minus c. So minus 1 by 2 as it is. Here cosine this plus this, which is 5x, minus this, which is cosine x. The whole bracket into sine x. Here dx, here dx. Okay. Remember, this is not difficult. This is 11th standard trigo. It's not a big task. Now again, we'll open the bracket. So if I open the bracket, cosine 5x into sine x minus cos x into sine x. Again factor formula. You need 2cs, you need 2cs. So multiply and dividing by 2 again. So minus 1 by 4. This is twice cosine 5x into sine x minus twice sine x into cos x. You know this is a known formula. Okay. So now here, this is 2cs. What is 2cs? If you remember, s minus s is 2cs. Okay. So minus 1 upon 4 here. 2cs is s minus s. You have 2cs. So answer is s minus s. Sine this plus this, which is 6x, minus this minus this, which is sine 4x. You know 2 sine x cos x is sine 2x. So you see what you did basically. You have reduced the product of trigonometric functions in form of plus or minus. That is 11th standard trigo. Now integration would be just one line. The final step is integration now. Integral of sine is minus cos 6x upon coefficient of x6. Here plus, this is cosine 4x upon the coefficient of x, which is 4, plus cosine 2x upon the coefficient of x, which is 2, plus c. That's your final answer. If you want, you can take just minus 1 by 4. Otherwise, this will do. So this is the required integral. This portion is 11th standard trigo. Remember, this is the 11th trigo. Right? It is not integration. This is just from product to sum or the difference. Integration is just one line, you might have noticed. Question number 7, which is very simple, so I leave it for you. Multiply and dividing by minus 2 there. Question number 8. 1 minus cos x upon 1 plus cos x. If you remember, this is a known standard formula. What is 1 minus cos x upon 1 plus cos x? It is just tan square x by 2, if you remember. Double angle formula. Tan square x by 2 is exactly 1 minus cos x upon 1 plus cos x. Now question is, how do we integrate tan square? So you know one of the points to remember, if you tan square and cot square, the only way is what? That identity here, sec square x by 2 minus 1. You know this. Right? This is the only way to integrate tan square, and for cot square, cosec square minus 1. Can we integrate this now? Answer is yes. This is a linear function. What's the integral of sec square? That is tan x by 2 upon coefficient of x by 2, which is 1 by 2, minus integral of 1 is x plus c. So 2 into tan x by 2 minus x plus c. Now you see, if I do the same question like this alternatively, you will realize answer might be a little bit different. If you recall one of the points, I told you somewhere in those points, if you have 1 plus or minus cos, take conjugate. See this point. If you have 1 plus or minus cos, take conjugate. So I'm doing by this way. You will notice what's the difference. So here, the same question, I'm taking conjugate. 1 minus cos x, 1 plus cos x, conjugate of this function. What's the conjugate of this function? 1 minus cos x upon 1 minus cos x. Multiply and dividing with the conjugate. So numerator is 1 minus cos x the whole square. 1 minus cos x the whole square. What's the denominator? A minus b, a plus b. So 1 minus cos square, which is sine square. That you know. Now just expand numerator expression. 1 minus twice cos x plus cos square upon sine square. Now this also, you know, if you have more number of terms, do individual division. So I'm doing individual division. 1 upon sine square, which is cos x square. You know answer here. Minus 2 as it is. Cos upon sine, it is cot. And you are left with one more cos, which is one more sine, which is cosec x. Plus cos square upon sine square, you know it's cot square. So you have this, remember. Now here, you can integrate this. What's the integral of cos x squared, which is minus cot, that you know. What is integral of cosec into cot? This minus 2 as it is. This is minus cosec, if you remember. Plus, can you integrate cot square? No. So here instead of this, as I told you, you need to write cosec square minus 1. What is integral of cosec square? It is minus cot. And what is integral of 1, which is x plus c? So your final answer is minus cot minus cos. So minus twice cot x. This is plus 2 cosec x and minus x plus c. This is also perfectly right. There is nothing wrong in this, remember. Both answers are looking different. But with little trigo, you can show that this is same as this. Right? So in subjective, whether I do this way or this way, both are perfectly correct. In MCQ, it makes a difference. In MCQ, if you are doing by this, but if you answer in this form, you need to keep your options in your mind, remember. But as far as subjective, if nothing is given, if I do this way, my answer is this. If I do this way, my answer is this. Both answers are correct, remember. In indefinite integral, this happens. That's why this is called indefinite integral. Indefinite integral means what? Final answer need not be same. By one student following this method, they are getting this. The another student getting this method, getting this answer. Both answers are looking different, but both are correct, remember. There is nothing wrong. Question number 9, you can try yourselves. It's very simple. I'll go to question number 10. So Sine raised to 4. This is a good question. Sine raised to 4, it cannot be integrated directly. So we need to use trigo. So what I'll do, I'll simplify function first. You can do like this also. How do? We know double angle formula. So I'll write squared whole square. Now use double angle formula. 1 minus cosine 2x by 2 the whole square. 1 upon 4 as it is outside. If you expand, 1 minus twice cosine 2x plus square of this, which is cos square 2x. Can you integrate this again? No. So we need to use double angle formula here. 1 upon 4. This is 1 minus twice cosine 2x. Use double angle formula. 1 plus cosine double of 2x, which is 4x the whole by 2. Take LCM here. 1 upon 8. 2 will come outside. 2 plus 1, 3 minus 2 into 2, 4 cosine 2x. 1 already counted here, so just you are left with cosine 4x. This is a simplification of function. Now you notice inside the bracket the function which you are getting can be integrated very easily. So now I'll come to integral. Therefore inside the integral, sine raised to 4 is this. So I'm just putting this equals to 3 minus 4 cosine 2x plus cosine 4x the whole dx. This is 11th standard trigo, remember. 1 upon 8 outside, integral of 3x minus 4 being constant as it is, integral of cos 2x is sine 2x upon the coefficient of x2 plus here sine 4x upon 4 plus c. This is your answer. If you want, you can take here 8 inside this. So 3x by 8 minus here 4 will get cancelled with this. So 1 upon 4 sine 2x plus 8 4s are 32 here. 1 upon 32 into sine 4x plus c. This is your final answer. So integration is just one step here, remember. Important one is trigo here. Cosine 4, I'll just give little idea. I'll not do that. 11th question. There the function is cos raised to 4 2x. So how we'll do this? As I told you, use double angle formula. So cos raised to 4 2x you can write as cos square 2x and then whole